right, so this is 7.5, day 2, which is still parametric equations, but we're going to move on to 2 new conic sections. So the conic sections of circle, ellipse, hyperbola, and a horizontal parabola are all not functions. The equation, and you can think of each one and they just don't pass the vertical line test. The equation of the conic sections are often written as implicit relations, making them difficult to read when it comes to calculus. To get around this difficulty, we're going to use parametric equations. The x and y variables are each expressed in terms of a third variable, usually t or theta. These 2 equations are individually functions themselves. So let's start with a circle. Let's start by looking at a circle. What's the rectangular equation for a circle? So recall that is x minus h quantity squared plus y minus k quantity squared equals to the radius squared. So it says let x equal cosine of t and let y equal sine of t, with t in between 0 and 2 pi inclusively. To figure out what the graph is, let's do some investigating. Let's write down the Pythagorean trigonometric identity that relates cosine and sine. So remember we learned 3 identities last semester, and one of them had sine and cosine in it. That one is sine squared plus cosine squared. Sine squared of theta plus cosine squared of theta is equal to 1. So the next thing says, well, what if we substitute x and y into the identity? So first off is sine the x value or y value. So y value, so that's y squared. Plus cosine is x, so x squared equals 1. And if we wanted to write this, that's a little bit prettier, x squared plus y squared equals 1. So remembering back to our trigonometry days, what specific curve does this represent? So if I asked you to graph that, what is it? It's a circle. It's a circle with center 0, 0 and radius 1. So it's also the unit circle. All right, so now it says let's practice using parametrics to plot the curve. Include direction. All right, so what I'm going to write down so that I can see it here is x is cosine of t, y is sine of t. So I have x of t is cosine of t, and y of t is sine of t. I could have just used the highlights from up there, but just so I can zoom in more. Okay, so what we're going to do is we're going to plug in 0 first, then pi over 2, then pi, so on and so forth. So I'm going to plug in 0, so I need the cosine of 0. Okay, so let's think about where 0 is. If this was the unit circle right here, 0 is right here, and I need to know the ordered pair because the cosine is the x value. Cosine is 1. So I can put a 1 here. And while we're at it, let's do sine. Sine is 0, right? So we can just think about it that way. We can write down the ordered pairs as we go around. So at pi over 2, which is up here, that is 0, 1. At pi, which is right here, negative 1, 0. 3 pi over 2 down here, that's 0, negative 1. And then back to 2 pi is 1, 0. So we get these 5 points. They're all order pair x comma y. You do not need to put parentheses around it in comma, but just so you can see the 5 points that I'm plotting. So I have 1, 0, and then I have 0, 1, negative 1, 0, and 0, negative 1. I'm going to try to make this look like a circle if I have to fix these points so that the circle actually goes through them. I can do that afterwards. Okay, it's not terrible. Well, it's off center a lot. Let me see if I can make it a little bit on center. And then move this point. Should I just leave it? No, I can't. Move this point over a little. Move this point over a little. Those two look okay. All right, so now I also have to show the direction. So remember, I have to say, like, where did I start? Started at 1, 0. And then I went this way to 0, 1. So my direction is this way. And then I'm going to show that it's going in this direction. So it says we say that this curve is parameterized in the blank direction. So I'm looking for either clockwise or counterclockwise. As you can see, this is counterclockwise. All right, so what if we wrote x as sine and y as cosine instead? With still t in between 0 and 2 pi. Use parametrics to plot the curve and include direction. So instead of doing cosine first, I want the sine value first. So I want this value first, which is 0, and then this value, which is 1, right? So this would be 0, 1, and I'm just going to look at each one of these and just flip it, because that's all that I'm doing is I'm switching sine and cosine. So this would be 1, 0, 0, negative 1, negative 1, 0, and 0, 1. And now I'll plot these points, and I'm going to get the same exact circle, right? So I have 0, 1, but I'm starting here instead, right? 1, 0, and I'm going in that direction instead. 0, negative 1, and then negative 1, 0. Connect these points to make a circle. Yeah, good enough. And then once again, I got 0, 1 first, and then I went to 1, 0. So I went in this direction. So I'm going to show that I went in this direction. If you look and see what this direction is, this is clockwise. So we say that this curve is parameterized clockwise in the clockwise direction. Okay, so when we are working with circles, we're going to end up having all of ours be counterclockwise because they're always going to be cosine sine. So make sure you are showing direction, but since they're all cosine sine, we're going to show counterclockwise. Okay, so it says now we know that the unit circle with center 0, 0 is x equals cosine of t and y equals sine of t. In parametric form, we can think of these as x equals 0 plus cosine of t, y of t equals 0 plus sine of t. This brings us to our general parametric form of a circle. For a circle with radius r and center hk, the parametric form with counterclockwise parameterization is written as, since it's counterclockwise, we're going to do cosine first. So h is first. Okay, whatever that is, whatever your center is, and then k would be with this over here. And then it's plus whatever your radius is, cosine of t. And this one is k plus whatever your radius is, sine of t. And that is going to be your two equations. So notice that, once again, cosine is going to always be with x and sine is going to be with y for everything that we're doing. So we're going to have counterclockwise direction. All right, so we have 4 examples total. What I would like to do is example 1 with you, pause, you try example 2 and check it with mine. And then the same thing, or I should say I'll do A with you, you try B on your own. And then same thing for example 2. Okay, so example 1 says convert the circles from rectangular to parametric form. So I'm going to start with that, okay? It says then identify the center and the radius and then plot the graph, include direction. All right, so I need to write my 2 equations. In order to do that, I do need the center and the radius. So I'm just going to get the center and the radius first. So center, radius. The center of this circle is negative 3, 2, and the radius is 4. So now I'm going to write my 2 equations. My first equation is x of t equals h, which is negative 3, plus my radius, which is 4, cosine of t. And then my next equation is y of t equals my k value, which is 2, plus r sine of t. So there's my 2 equations. And then there is my center and my radius. Okay? So these 2 equations separately are functions themselves. It's the top and the bottom of the circle. Okay? But that's why we're actually doing this. So now we can graph it. You can look at this and graph it. You can say the center is negative 3, 2, and the radius is 4. Or you can look at what you wrote down already where the center is negative 3, 2, and the radius is 4. So let's go ahead and graph that. Negative 3, 2. Radius is 4. So I'm going to go up 4. I'm going to go down 4 from that point. I'm going to go right 4. And I'm going to go left 4. I'm going to go ahead and connect these 4 points, and then I'm going to show the direction. Since it's cosine sine, it's counterclockwise. Once again, we're going to do all cosine sines, so all of ours will be counterclockwise. All right, go ahead and pause the video and try the next one on your own. All right, let's see how you did. You should have gotten your center is 3, 0. and your radius is the square root of 41, which is not simplifiable, so I can leave it like that. So I have x of t equals 3 plus cosine of t, oops, I forgot my radius, 3 plus root 41 cosine of t, and then y of t is equal to 0 plus, so since it's 0 plus, I'm just not going to even bother writing it, root 41 sine of t. And these are my two equations. Now I'm going to go back to my first two, make sure I put sine in the second equation. I did. Here's my other information they asked me for. And now I'm going to graph this. I'll start by graphing my center, which is 3, 0. I need an approximation of root 41 because I have to get an approximate radius. So root 41 is a little bit more than 6, so 6 point something. It's more than root 36, but less than root 49. So I'm going to go to the right 6 and a little bit more, to the left 6 and a little bit more, up 6 and a little bit more, down 6 and a little bit more. And then I'll go ahead and connect these points to get my circle. And then once again, don't forget to show your direction. This is counterclockwise. All right, next we have equations that are in parametric form. And it says, first identify the center and the radius, use the parametrics to plot the graph, include the direction, and then write it in rectangular form. So let's try to do it in that order. Let's do the center and the radius first. Center, radius. All right, our center is HK. So that is 2, and then there's nothing in front here. There's a 0 right here, so 2, 0. And then my radius is 6, because that's what's in front of my cosine and my sine. So there is my center and my radius. It says graph it now. I can do that. 2, 0. Right 6, left 6, up 6, and down 6. Show your direction after you're done graphing your circle. Remember, since it's cosine sine, it's going to be counterclockwise. Last, it asked me to write it in rectangular form, so I'm going to use my center and my radius to do that. So I have x minus 2 quantities squared plus y minus 0 squared, which I'm just going to write as y squared, equals r squared. 6 squared is 36. And there's my equation of my circle. All right, go ahead and pause the video and try the next one on your own, and then check back with me. Center, radius. The center is -2, 4, and the radius is 8. You can go ahead and graph that. Left 2, up 4, and a radius of 8. So I'm going to go up 8 to 12, down 8 to -4, right 8 to 6, and left 8 to -10. And then go ahead and connect. This is a really big circle. Try to go fast. There we go, to get it fixed. And then counterclockwise because it's cosine sine. Last, I want to write it in rectangular form, so I'm going to use this to write it in rectangular form. That's x minus negative, so plus 2 quantities squared, plus y minus 4 quantities squared is equal to r squared, 64. And there's the equation of your circle. Okay? All right, so let's move on to ellipses. So first thing it asks us about ellipses is what's the rectangular equation of ellipse? We have a vertical and horizontal ellipse. Let's just write down the horizontal equation. So that's x minus h quantities squared over a squared plus y minus k quantities squared over b squared is equal to 1. All right, so now it says let x of t be 2 plus 3 cosine of t, and y of t is -4 plus 5 sine of t. What is the difference here from the previous examples that we just did? Well, if you look at the number in front of cosine and sine, this is a +3 and this is a +5. Those two numbers aren't matching anymore. So since these two numbers, well, that's not supposed to happen. Since these two numbers right here don't match, this is not r. So this is not the same. So not a circle, right? It can't be the r value, therefore it's not the radius, it's not a circle. Ellipses have almost the same parametric equations as circles. The only difference is for an ellipse, the number in front of cosine and sine are different. This means that the parametric equations for an ellipse with a counterclockwise parameterization with center HK, horizontal radius A, and vertical radius B is x of t equals, it's still h plus, and then instead of r, you're going to take the a value cosine of t. And then y of t is k plus b value sine of t. So notice, still cosine sine, so it's still going to be counterclockwise. Okay, so once again, same idea here. I'll do both a's with you. I'd like for you to try both b's and then check back. Convert the ellipses from rectangular form to parametric form. Use parametrics to plot the graph. And then include direction, and then don't forget to identify the center in both radii. So I need the center, and I need the both radii, meaning the horizontal radius and the vertical radius. The horizontal radius is A, the vertical radius is B. All right, so I need my center to graph, and I need my radius to, I need my center to graph, and then I need my horizontal radius and my vertical radius. It asked me to write it in parametric form first, but I need my center and my A value and B value to do that, which is like all the same thing. So the order really doesn't matter of how you do it. So I'm going to get my center, my horizontal radius, and my vertical radius first. So the center of this ellipse is negative 3, 2. Horizontal radius is A. So A squared is 3. B squared is 64. Now if you're like, wait, A squared is 8 because it is the bigger number in an ellipse. But we're going to do horizontal and vertical radius instead. So it's really just, we're using this equation only right here. And it's going to be the first one we're going to look at to get the horizontal radius. The second one we look at to get the vertical radius. So the horizontal radius is 3 and the vertical radius is 8. So just find horizontal first. The first one's horizontal, the second one's vertical. Okay, so I can graph this now, or I can write my equation, my parametric equations. I'm going to do that. X of t equals, I need h, which is negative 3, plus 3 cosine of t. So this is always going to be a squared. This is always going to be b squared because we're going to say that a is the horizontal radius and b is the vertical radius. So we have y of t equals 2 plus 8 sine of t. So there is my two parametric equations. Here's my important information. Now let's graph it. So we are going to graph the center at negative 3, 2. And then we have a horizontal radius of 3. So we're going to go right 3 and left 3. And a vertical radius of 8. So up 8 and down 8. So as I add 2, I go to negative 6. So if you're like, wait, isn't it changing what we did before? Like, no, this is still a vertical ellipse if you look at it, and I'm still making a vertical ellipse. I still went up and down 8 units and not left and right. Oh, that's interesting. I still went up and down 8 units and not left and right. So it's just another way of looking at it. So there's my ellipse. It's cosine sine, so it's going to be counterclockwise. All right, go ahead and pause the video and try this one on your own. All right, so first off, what you should notice is that the square is on the outside of the parentheses. So this is the same thing as x squared over 4 plus y plus 1 squared over 9 equals 1. It's just that they already pulled the square out of both of them. All right, so I need my center, and I need my horizontal radius and my vertical radius. And then once I have these, I am going to write my two equations. All right, so my center is 0, negative 1. Horizontal radius is 2. Vertical radius is 3. So remember, you're doing horizontal radius, vertical radius. Don't call them A and B because then you're going to end up confusing yourself. All right, so 0, negative 1. Center. Horizontal radius 2, so right 2, left 2. Up 3, down 3. This is my ellipse. Show your direction, which is counterclockwise. And then I also still have to write it in parametric form. So I have x of t equals 0, so I'm not going to write it down, plus 2 cosine of t. Y of t equals -1 plus 3 sine of t. So there's my parametric equations, and here is my information. All right, last two here. We're going to do the first one together. Try the last one on your own. First, identify the center in both radii, meaning the vertical and horizontal. Use parametrics to plot the graph, include direction, then convert the ellipse from parametric to rectangular form. So I'm going to start off by getting my center, my horizontal radius, and my vertical radius. All right, so my center is 3, -1. My horizontal radius is 2. My vertical radius is 6. I'm going to graph it now. 3, -1. Horizontal radius is 2, so I'm going to go right 2, left 2. And then vertical radius is 6, so up 6 and down 6. I'm going to go ahead and make my ellipse and show my direction of counterclockwise. And then let's go ahead and write it in its standard form. So that's x minus h squared, which is 3 squared, over the horizontal radius squared, which is 4, plus y minus 1, so y plus 1 quantity squared over my vertical radius squared, 36 is equal to 1. So there's my equation. If you look at that, you can tell it's a vertical ellipse. We drew a vertical ellipse, and it's all matched up. All right, go ahead and pause the video and try the last one and then check back. You should have your center is 0, -4. There is no h value here. This is 0 plus. And then I get my horizontal radius is 8, and my vertical radius is 3. Go ahead and graph that. 0, -4. Horizontal radius is 8, so right 8 and left 8. Vertical radius is 3, up 3, and down 3. You can go ahead and make your horizontal ellipse this time. Show your direction, which is counterclockwise. And then go ahead and convert. So I have x minus h squared, which is just x squared. So I'm going to erase my parentheses and just put x squared. Over your horizontal radius squared, 64, plus y minus a negative, so plus 4 squared, over my vertical radius squared, which is 9, equals 1. If you look at the equation, this is still a horizontal ellipse. I'm not worried about, the 4 and the 9 are in the wrong, the 64 and the 9 are in the wrong spot, because they're not. The first denominator is your horizontal radius squared, and your second denominator is your vertical radius squared. All right, that's it for today. You can go ahead and do the homework, which is the review for tomorrow's